Hello again, and welcome back to another episode in the series Getting Funky with Flow, a result type for C# developers. Today we're stepping things up a notch by flowing results across the wire using JSON serialization. To make this more realistic, I've added a few more projects to the solution. We'll send a request to a web server, which then dispatches it to a handler in the application layer. The application layer defines a few interfaces, and the infrastructure layer provides their implementations. I've skipped adding a domain project for now. It's not needed for what we're doing today, but who knows, I might include one in a future episode. From an architectural perspective, this setup leans towards CQRS. For data access, I'll be using one of two DB context instances, which is my usual approach. I typically create two contexts per database, one for reads and another for writes. Let's quickly run through the projects you can see on the right in the Solution Explorer. Towards the bottom of the screen, we have the infrastructure project. This contains our data access code, which uses Entity Framework Core. It connects to a small SQLite database that includes just 3 tables from the old Northwind database, which brings back memories. I first encountered Northwind way back in Microsoft Access version 2. Above that, we've got a contracts project. This holds any types or objects that need to be shared between the server and client, since we're working in an end-to-end .NET setup. Then we have the application project. This is where the actual work happens. It's where we orchestrate our use cases, handlers and core logic. Above that is a project I've simply called Web Server. This acts as the entry point into our demo system. For today's episode, it's exposing a basic API controller, but in the next episode we'll be switching it up gears and using gRPC services instead. And finally, we've got the console client, which we'll continue using for output and interaction, basically our presentation layer. Now let's go through the main players, starting with the IDB exception handler interface. If you remember from the last episode, we used a JSON file exception handler method to wrap exception handling logic. At the time, I mentioned that this could be abstracted behind an interface. The IDB exception handler interface, defined in our application project, provides the contract. It simply needs a single method to be implemented that accepts an exception and returns a flow. The concrete implementation for this is the SQLite exception handler, which handles exceptions specific to the SQLite data provider. This implementation is injected into any handler that requires it. Next up, the file containing both the query and its handler. I like to keep them together in one file. It keeps things tidy and makes it easy to follow. The query itself is just a simple record. It holds the ID of the supplier whose view that we want to retrieve. The handler uses a primary constructor to inject two dependencies, the read-only DB context and the IDB exception handler. Since we're not yet inside a flow, and we want to ensure our data access code is wrapped in a try-catch block, we use the flow handler utility class, specifically its try-to-flow method, which we introduced in the previous episode. I encourage you to download and explore the code, but in short, we query the suppliers table for a few details and a count of the number of products sourced from the supplier. We don't need any manual mapping or includes. The projection method, project to supplier view, generates a SQL needed to populate our supplier view object, which is defined in the contracts project. Now here's an important bit. When you look up a single item in a database, what happens if it's not found? If you use single or default async, you'll either get the item or a null. If you use single async, you'll get the item or an exception. Before we move on, Take a moment to think about how you'd handle this in a typical application without a result type like flow, especially if your method is supposed to return a supplier view. You could throw a custom exception, then catch it in the API controller and convert it into a problem details response. You could return null, then check for that in the controller and respond with a specific status code or header, leaving it for the client to interpret. You could make the return type a collection and return an empty list of if nothing was found, again hoping that the client understands what that means. Or you could use a result type like flow and explicitly return a failure when no item is found without relying on nulls, exceptions or custom response plumbing. And that's what we do. If the result is null, we create a failed flow using the item not found failure class. Simple and clear. That handles the not found scenario. Other failures, like database exceptions, are handled by our injected IDB exception handler, which knows how to translate exceptions into failures and return them through the same flow pipeline, again without throwing or returning nulls. Now let's turn to our suppliers controller. Here I'm using the instruction dispatcher that we built in a prior video to route commands and queries to their respective handlers. I'll admit it can seem a little black boxish, but under the hood it's just autofac doing assembly scanning to find and register handlers based on their interfaces. If you prefer a more explicit approach, you can invoke the handlers directly, but either way you'd want to register them through an IOC container to resolve their dependencies. Finally, take a look at what's not in the controller. No try-catch blocks, no null checks, no custom response headers, no problem details. Sure, this might be a demo, but this is exactly how my production apps are structured and I have zero issues with them. On the client side, I've added support for the HttpClient factory to create HttpClient instances, along with a custom delegating handler that sits in the message pipeline. Now, while we're not actively using this handler in today's episode, all requests will still pass through it. I included it so you can see how all the pieces fit together, and in future episodes I may show more targeted use cases for it. The HttpClient delegating handler currently on screen is the implementation. As you can see, it does nothing. It's a placeholder to demonstrate where additional logic could go. Next we have a small but powerful extension method I wrote. It operates on task of HTTP response message and converts it into a flow of T. I'm currently considering including this in the Flow NuGet package because, to be honest, I've never needed more than what's shown here, but that's a discussion for another day. The main purpose of this extension is to catch unhandled server-side errors or handle scenarios where the server isn't even reachable. It wraps the response in a flow, making it compatible with the rest of our pipeline. Finally, we come to today's example code, which sends a request to the API controller providing the supplier ID of the view we would like to retrieve. The controller builds and dispatches a query to its handler, which then queries the database and constructs the required view. If all goes well, we'll receive that view back as a successful flow of supplier view. Let's walk through the client code so we know exactly what to expect. On line 21, we create a new HttpClient instance and pass it into the getSupplierView method, along with the endpoint path that includes a placeholder for the supplier ID. Now, you may have noticed when we looked at the controller that there was a simple getSupplier endpoint that returned a boolean. That's just a utility endpoint I added to check if the server is up and running. Inside the if block, we use the standard HttpClient JSON extension. Because these methods automatically extract the response content and deserialize it, there's no HTTP response message left for us to attach an extension to. That's important. Without wrapping this in a try-catch block or using a global error handler, any server outage or unhandled exceptions will cause problems, just like it would for any normal HTTP client usage. That's why this block is isolated. You'll see why that is in a minute. For the first request, we'll use a supplier ID that doesn't exist. We expect this to result in a failed flow, not because of an exception, but because the database returned null, which we then wrapped in a failure manually. It's still a failed flow and behaves exactly the same as any exception-based failure. The second request uses a valid supplier ID, so we expect to receive a successful flow containing a supplier view. The final request, outside of the if block, shows how I typically structure production code. It avoids the HttpClient JSON extension and instead uses the standard HttpClient methods, which returns a task of HTTP response message. This allows me to attach a custom try-catch JSON result extension, which wraps the deserialization and error handling into a clean flow, regardless of whether a delegating handler is present. Alright, showtime, let's run the app. The first request may take a couple of seconds as the server starts up and initializes everything. After that, the remaining calls should be instant. As expected, we get one failure result, followed by 2 successful views. I'll repeat this a few times. You'll notice the supplier ID changes with each call. Currently, my launch profile is set to start both the web server and the client console. But now, let's shut everything down and try something different. We'll start just the console app to simulate a server outage. Personally, I find the easiest way to do this is to right-click the console client project, go to the debug menu and select Start New Instance. This way, you don't need to modify your solution's startup settings. Now, because I didn't want the app to crash during the first 2 requests, the isAlive check is used to skip those requests in this scenario. And as expected, we get a problem has occurred message printed to the screen. Let's double check that that is our message. Sure enough, the unhandled exception was caught by our extension and converted into an unknown failure, complete with the original exception message. As I mentioned briefly in episode 2, I truly believe that a result type can simplify your code significantly, especially when you're working in an end-to-end .NET setup. That's enough for today, so let's wrap it up. In the next episode, we'll take things a step further and explore scenarios using gRPC. As always, feel free to leave good or bad comments and I'll do my best to answer any questions raised. If you found this episode or source code helpful, please consider liking and subscribing to help support the channel. These videos take time to produce and it really helps me to know they're reaching people. Getting just a handful of views for hours of work isn't the most motivating thing, so every bit of engagement makes a big difference. Anyway, thanks for watching. Until next time, bye for now.